110 today. What happened to the smell anyway? Anybody know? Bummer. So in section 21.7, we have a rule that says if I take the derivative of some function raised to the n, then with respect to some variable, then I'm going to have n u to the n minus 1 times the derivative of that function, whatever it is, with respect to x. So if y is equal to 7x squared plus 2x minus 3 raised to the 10th power, then y prime would be 10 times 7x squared plus 2x minus 3 raised to the 9th power times the derivative of what's on the inside, 14x plus 2. Okay, so if I had y is equal to the sine of the cosine of x squared plus 4. Now we can't do that one because we don't know what the sines and the cosines. So you just got to take my word for it when I write down the answer, right? So y prime is going to be minus the cosine of x squared plus 4 times the sine of x squared plus 4 times 2x. So I just continue doing it, taking the derivative of the inside thing of the inside thing of the inside thing forever and ever, and then multiplying them together. So I'll do it one more time. Y is 2x plus 1 to the 4th raised to the 5th. Well, I would just call it 2x plus 1 raised to the 9th, right? And work it that way. Y prime 5 times 2x plus 1 raised to the 4th times 4 2x plus 1 raised to the 3rd times 2. So that's what I would do. But if I were to do the same, if I would work the same problem over again and say that it was my original problem is 2x plus 1 raised to the 9th, then I'd say that that'd be 9 2x plus 1 raised to the 8th times 2, which is exactly what I have here, right? Maybe, I don't know. There's my 9, there's my 2. Maybe I've got that there. It's hard to say. And then we got a thing called the chain rule. Don't let Vice President Biden know about this, or he'll use it in his next speech. The chain rule. So if I have the derivative of some function with respect to x, then that's the same thing as the derivative of that function with respect to some other variable times the derivative of that variable with respect to x. I can do that. Well, why I want to do that for, but we'll probably find out later. Okay, we're doing the homework problems. I'm starting with number 2. Y is 5x squared minus 7 to the 16th, and y prime 16 times 5, 90, 80, 80 x squared minus 7 to the 15th times 2x. I could rewrite that if I wanted to, but I don't necessarily have to. I could rewrite it like that if I wanted to. I could then go and use Pascal's triangle to expand that guy, but I'm not going to do that either. Number 4, y is x to the 4th, 3x squared plus 1 raised to the 6th, y prime 6 times 4 x to the 4th minus 3x squared plus 1 raised to the 5th times 4x cubed minus 6x.
Easy, please. Easy, please.
I know, it's just pathetic how simple this stuff is. Why they kept this from you your entire adult life, I don't know. Y is equal to 1 over 3x to the 4th minus 2x plus 3 cubed. I would never work that problem. I would work a different problem. I would work 3x to the 4th minus 2x plus 3 to the minus 3. That would be the problem that I would work. And I would say y prime is equal to minus 3, 3x to the 4th minus 2x plus 3 to the minus 4 times 12x to the cube minus 2. And then I might rewrite that because I have a negative exponent. 12x cubed minus 2 times minus 3 divided by 3x to the 4th minus 2x plus 3 to the 4th power. Okay, and I might even more, I probably wouldn't. I might factor out a 2 out of there, but that looks like too much work. Number 8, y is the square root of 4x cubed plus 2x squared minus x. And again, I'd never work that problem. I'd work a different one. 4x cubed plus 2x squared minus x raised to the 1/2. So y prime would be 1/2 4x cubed plus 2x squared minus x to the minus 1/2 times 12x squared plus 4x minus 1. And then I'd probably rewrite that as 12x squared plus 4x minus 1 divided by 2 the square root of 4x cubed plus 2x squared minus x. Now, why is it that we do a shit pot of derivatives? Any idea? Well, the next thing we're going to do is take integrals, which are the opposite way. So if I saw this guy and I said I wanted I can't use blue. Can I use green? Okay, so if I take the integral of this guy, I'm supposed to get the original guy back. So if I take a shit pot of derivatives, then I have the form in my head and I know what the form looks like, and now it's easier to, when I go the opposite way, to take an antiderivative, which is the integral. Okay, so that's why we do that. We're supposed to go all the way up to where? 29. Well, we'll drop down to 18. No, we won't. I don't have a marker to draw with 18. Y is x squared minus 2 cubed 3x minus 4 squared. Now, we could expand those guys and make it easier on ourselves, but we'd probably make a mistake doing it, right? 3x squared minus 2 squared times 2x times 3x minus 4 squared plus x squared minus 2 cubed times 2 3x minus 4 to the 1 times 3. And then, we might want to clean that up, or we might not. I wouldn't. I just leave it like that. Okay, moving on to number 24.
You got a question on that?
Yeah.
Where does that 2x come from? They have it right in the middle, on the top?
Right here.
Oh, okay.
So the 3 goes out in front. I subtract 1 from the 3. I take the derivative of this. I get 2x. I then multiply it by that, and then I plus the thing at the beginning times the derivative of this thing. 2 goes there. That becomes a 1. I don't write it, but there's a 1 sitting there.
I got you.
And the derivative of this is 3. I put it there.
Got you.
Yeah. I know it looks like I'm making a mistake, but
No, I just see where it's coming.
yeah. 5x minus 2 cubed minus 1 minus x to the 4th. Okay, so y prime 3 5x minus 2 squared times 5 minus, which will become a plus later on, 4 1 minus x cubed times minus 1. And at that point I'd probably rewrite that guy because I'm that type of person. 15 5x minus 2 squared plus 4 x minus 1 minus x cubed. Okay, good enough. Moving on to section 21:10. 21:10. I don't, if I had y is equal to 3x to the 5th, then I could have y prime 15x to the 4th. I could have y double prime of 60x cubed. I could have y triple prime 180x squared. I could have y to the 4th derivative 360x, y to the 5th derivative 360, y to the 6th derivative 0. And from there on, all the 7th derivative would be 0, the 8th derivative would be 0, all the rest of them would be 0. So I'm not limited in taking derivatives of just the function. I can continue taking the derivative on and on and on until I run out of derivatives to take. There are some circular functions out there. So if y is equal to sine x, then y prime is cosine x, and y double prime is minus sine x, and y triple prime is minus cosine x, and y, the 4th derivative, is sine x, and I start all over again. So in that particular case, I end up starting over again. I could take derivatives out to infinity, and I would still only get either a sine or a cosine or a minus sine or a minus cosine. I could do that forever. But those are special type things. In our physics book, as long as acceleration A is constant. If it's not constant, then something else is happening. Then velocity is going to be my position, the change in position, change in time, and my acceleration is going to be the second derivative of position with respect to time, as long as acceleration is constant. Oh, yeah, I guess that's right. All right. So now we're doing problems. And this time we only go to 13. So either these are harder or I just didn't assign very many, one or the other. So number 2, we want to find the first 4 derivatives. All right, so y is 3x to the 6th minus 8x cubed plus 2. Y prime. 18x to the 5th minus 24x squared. Y double prime. Minus 48x 90x to the 4th. The triple derivative, third derivative. Minus 48 360x cubed. And the fourth derivative, sometimes you'll see it written y to the IV in parentheses. Sometimes you see it written y to the 4th in parentheses. Very rarely do you see it 1, 2, 3, 4 like that. That would be improper for a normal math person to say that. Oh, what is this? 1080? 1080x squared. Okay, so once you get started, you just don't stop. That's the bottom line. Number 4. Y is where? What's the derivative of a constant? Look in the back of your book. Derivative of a constant is 0, number 1. All right, no problem. So when in doubt, look in the back of the book. Apply the rule that applies. If you don't see a rule, then open your eyes that I may see. Let's see, plus 4x minus 7. Y prime equals 6x plus 4. Y double prime equals 6. Y triple prime equals 0. Now it wants us to find the first 4 derivatives, so we still have to find y4, and it's still going to be equal to 0, but that's what he said. Find the first 4 derivatives, so that's what we did. Well, the kids from CMA today that we had in over there, really cool kids, just like you guys are. But they have been brainwashed really bad by the education system. They actually thought global warming was real and not a political thing. And they were amazed to find out that Ohm's law is real and global warming is just a theory and isn't real. It's a belief system. They were totally amazed. Anyway, their instructor knew that, but they had been so brainwashed by the school system, by their liberal arts instructors since kindergarten, they actually thought that global warming was real. Can you imagine that? In America, that happening to us? Find the indicated derivative. All right, so y is equal to, and I would never solve this problem because this is a pain in the butt problem, right? Oh, wait a minute. That's an x squared? At least I could write the problem down right. All right, so I would solve the problem y is equal to 3x to the minus 2. That would be the problem that I would be solving. Because if I could do this, and I could use the quotient theorem over and over again, the u v prime minus v u prime divided by v squared, but I would be making a mistake sometime during it, and I'd be hosed. All right, so minus 6x to the minus 3, y double prime, 18x to the minus 4. Y triple prime, which is what they want me to find. Now there's no way to find the third derivative without finding the first and the second one, gentlemen. Okay, there's no shortcut here. Let's see, 4 times 8 is 38, minus 72, right? X to the minus 5. think I did that right. Okay, number 8.
Change that back to level negative.
Well, the first guy's positive, but the next guy's negative because it's minus 2 times 3 gives me minus 6. Then it's minus 3 times minus 6 giving me a positive number.
Yeah.
Then minus 4 times 18 giving me a negative number.
What I meant was, where'd you put the?
Oh yeah, okay, I understand what you're saying. You're objecting to the spelling.
Yeah.
Okay, minus 72 over x to the 5th. So that'd be better? Okay. And Andy's, are you objecting to anything, Andy, or like my multiplication of 4 times 18, for example?
I think his beard's clouding a bit.
His beard is clouding his, oh yeah, it has nothing to do with the pink screen of death. All right. Number 8. Okay, so y is equal to, I got a parentheses, 4x squared minus 2 raised to the 4th power. And I want to find the second derivative. Okay, so y prime for 4x squared minus 2 to the 3rd power times 8x. Okay, now normally I wouldn't combine things, but now I'm going to combine things because that'll make it easier for me. 32x 4x squared minus 2 cubed. Okay, so now I'm looking for the second derivative, and we'll spell it the same way the question is. So we want the second derivative with respect to x. So I've got 32 4x squared minus 2 cubed plus 32x times 3 times 4x squared minus 2 squared times 8x. Okay, and I might clean that up some, maybe, I don't know. Something tells me I'm missing something. Nope, not missing anything. Alright, 32 4x minus 2 plus 2. 4x to the 2 squared. 4x squared minus 2 cubed plus 8 times 3 times 32. Well, beats the heck out of me. 32 times 3 times, it's 5 already. 32 times 3 times 8. That ain't right. What am I in? Some fanciful thing here? 32 times 3 times 8. And I was pushing the addition button is what I was doing in case anybody was wondering. 768x. 4x squared minus 2
It's going to be x
squared.
768 squared.
Oh, are there 2 x's? Yeah, there's 2 x's squared. You're absolutely right. Okay, so that, are we done with that one? What was that? That was 8. Number 10. I want the 4th derivative. Oh, bummer. Y is 2x plus 1 to the 3 halves. Okay, so the first derivative, 3 over 2, 2x plus 1 to the 1/2 times 2, y prime. 3, 2x minus plus 1 to the 1/2. Y prime. Y double prime. 3 over 2, 2x plus 1 to the minus 1/2 times 2. Y double prime. 3, 2x minus plus 1 to the minus 1/2. Y triple prime. Minus 3 over 2, 2x plus 1 to the minus 3/2 times 2. Y triple prime. Minus 3, 3x plus 1 to the minus 3/2.
2x plus 1.
Y, the fourth derivative, which is what I'm looking for, 9 over 2, 2x plus 1 to the minus 5/2 times 2. Final answer. Y, fourth derivative. 9, 2x plus 1 to the minus 5/2. Right. What we'll do is we'll come up in Maple and see if Maple gives us the same answer. And if it doesn't, then we'll fire the instructor and hire a new one. Good plan? Oh, okay. All right, so I got...
9 over 2x plus 1.
No?
Raise
No?
it possible.
Oh, yeah, you make it positive, yeah.
Comparison.
All right, so we have 2 times x plus 1 raised to the 3/2. Oh, bummer. Plus 1 raised to the 3/2. Now, why is this so big? Oh, you can't see the blue? Oh, bummer! You can't see the blue. I was sort of hoping you couldn't see the blue.
It's like imprinted in my retinas.
All right. There, is that bad? Now, so I want the first derivative, and I don't know if it's going to do this or not. There we go. And then I'm going to take the derivative. See, if I use the percent key, it takes the derivative of the guy preceding. Yeah, we had 1/2.
Well, there it goes.
If I bought Maple, could I use it on a test?
Probably not. It's too complicated. Never figured it out. Okay, so is that it? Is that the right answer? Positive 9 divided by that. Yeah, exactly. So that's the exact same answer. You'd have to have a computer to have it on.
Yeah.
So you bring a laptop in and you do it. How many cares if he uses Maple on his next test or not? Yeah, no one cares.
Yeah, Joel, of course.
Yeah, I don't see any problem with that.
All right.
I mean,
I'm not going to.
the amount of work you'd have to use to be able to use it would be substantial enough to allow you to use it without any loss of generality. Yeah, if that makes any sense. It's sort of like if you have a TI, just like if you have a TI-89 I allow you to have the manual for the TI-89 with you because the TI-89 is useless unless you have the manual.
Yeah.
Yeah, same type of thing.
All right. But that book usually have used the TI-89.
Well, it might, but then you'd have to take the effort to do it, right? All right, so what are we doing? We're going to 13, so that means when I do 12, I'm done. 12 and done. Y equals 4 times x squared plus 5 squared to the minus 2. And I only want the second derivative. All right, so seeing that maple works so well, we'll just do it in maple and then, oh, bummer.
No.
All right, y prime equals minus 8 x squared plus 5 to the minus 3 times 2x. Y prime equals minus 16x x squared plus 5 to the minus 3. Y double prime equals, okay, so I got minus 16 divided by x squared plus 5 cubed.
Just go up a little bit after you're done.
We'll hang out there for a little while. Long enough? Alright. So I did the first one. This looks like plus 48x. 48x x squared plus 5 to the minus 4 times 2x. Alright, so looks to me like y double prime had best be 96 x squared over x squared plus 5 to the 4th minus 16 over x squared plus 5 cubed. So that would be my best guess. No, that'd be the right answer, period, the end. But other than that, all right, so back to maple. And I've got 4 divided by parentheses. What in the world? 4 divided by parentheses x. I knew where the x was. Squared plus 5 raised to, that's not raised to, raised, oh, parentheses. Where's my parentheses? Parentheses raised to the second. Okay, so I'm okay? I'm okay. Right, and I want the derivative of the guy on top. And then I want the derivative of the guy on top. Not only that, but it spelled it right. Notice that Maple put the positive guy first and the negative guy second, just like he was supposed to. Way to go, Maple. So Maple does believe in your 9th grade algebra teacher. It does. It's not going to give you negative exponents, and it's going to put the negative guy after the positive guy. That is really cool. Is that what I got? It is? Okay. Whatever you say. Okay, good enough? All right. So that means we're done with chapter 21. And that means we do a review. No, we're not done. Yeah, we're done with 21. That means we do a review on Monday and a test on Wednesday. Yay! Yippee!
Almost done with the semester.
Almost.
Yellow.